In this section, we're going to look at how we calculate with logarithms, and we're going to define a number of properties of logarithms that will help us calculate, or an algebra of logarithms, so to speak. We can derive algebraic properties of our new function by comparing derivatives, and we can in turn use these algebraic rules to perhaps simplify the natural logarithm of products and quotients, and this is going to be especially useful in logarithmic differentiation. So let's start by assuming that a and b are positive numbers and that r is a rational number. It's of the form m over n, where m and n are integers. Our first property is a familiar one. It says that the natural log of 1 is 0. And this follows from our previous discussion on the graph of the logarithm and the definition of the logarithm. Our second rule says that the natural log of a times b equals the natural log of a plus the natural log of b. I'm going to justify this rule using derivatives. We're first going to show that for x a variable and a fixed number, the natural log of a times x is the natural log of a plus the natural log of x, where a is positive, and this holds for any value of x greater than 0. So then we'll substitute x equals b, and our rule will follow. Let f of x be log of x for x greater than 0, and g of x is the function the natural log of a times x, where x is greater than 0, a is greater than 0. When we differentiate both of these functions, we get the derivative of f is 1 over x, and the derivative of g using the chain rule is 1 over a times a, which again is 1 over x. Now from calculus 1, you know that if two functions have the same derivative, then they must differ by a constant. So we must have a constant c for which f of x plus c is equal to g of x. Now we can actually find the value of this constant by substituting, say, x equals 1, and in that case we get an equation, the natural log of 1 plus c equals the natural log of a, so this tells us c has to be the natural log of a. So then we get the natural log of a times x is the natural log of a plus the natural log of x, and now if I put b in there instead of x, I get rule number 2. Well, our third rule tells us how to deal with quotients. The natural log of a over b equals the natural log of a minus the natural log of b. Notice that 0 is the natural log of 1, which is the natural log of a over a, which is, in turn, the natural log of a times 1 over a. And by our previous rule, rule number 2, that's the natural log of a plus the natural log of 1 over a. So this tells me that the natural log of 1 over a has to be minus the natural log of a. And likewise, the natural log of 1 over b has to be minus the natural log of b. Therefore, we get the natural log of a over b is the natural log of a times 1 over b, which is the natural log of a plus the natural log of 1 over b, which is the natural log of a minus the natural log of b. Our next rule tells us how to deal with powers when we apply logarithms. It says that the natural log of a to the r is r times the natural log of a. So again, we are going to compare the derivatives of two functions, the natural log of x to the r and r times the natural log of x. So starting with the derivative of the natural log of x to the r, this is equal to 1 over x to the r times the derivative of x to the r by the chain rule, which is r times x to the r minus 1 over x to the r, and after cancellation, that's r over x. And note that that's also equal to the derivative of r times the natural log of x. So therefore, these two functions are related by a constant. We must have the natural log of x to the r is r times the natural log of x plus some constant. And once again, we can find the value of that constant. If we plug in x equals 1, we get the natural log of 1 is 0. Therefore, we get the natural log of x to the r is 0, and r times the natural log of x is 0, and we get c equals 0. And this tells us that the natural log of x to the r is r times the natural log of x, and then we can plug in any value of a for x and find our rule. Well, how do we use these rules? Suppose we apply the logarithm to x squared times the square root of x squared plus 1 over x cubed, then we can use our logarithms to expand this function. So we have 4 rules at our disposal. Natural log of 1 is 0. Natural log of a times b is the sum of the logarithms. Natural log of a over b is the difference of the logarithms. And the natural log of a to the r is r times the natural log of a. So we're going to start with rule number 3, and we're going to expand the natural log of x squared times the square root of x squared plus 1 over x cubed as a difference of the logarithms, the natural log of x squared times the square root of x squared plus 1 minus the natural log of x cubed. And once we've done that, we're going to separate this product. We get the natural log of x squared times the square root of x squared plus 1 is the sum of the logarithms of x squared and the square root of x squared plus 1. And then we'll use rule number 4 to work on the powers. So we get 2 times the natural log of x plus 1/2 the natural log of x squared plus 1 minus 3 times the natural log of x. And finally, when we calculate 2 times the natural log of x minus 3 times the natural log of x, we get minus the natural log of x, so we can tidy up to this bottom line, which says that that function is 1/2 the natural log of x squared plus 1 minus the natural log of x. Now, it's important to practice this before you work on logarithmic differentiation. Now, suppose I want to go in the reverse direction, and instead of expanding, I want to express this function as a single logarithm. Well, now I have to use the rules in reverse. We can, first of all, take care of the powers. With the reverse of rule number 4, we can express 1/2 the natural log of x plus 1 as the natural log of the square root of x plus 1, and 3 times the natural log of x plus 1 as the natural log of x plus 1 cubed. And now, combining those first 2 terms, we get, using rule number 2, the sum of the natural logs is the natural log of the product. So we can combine those first 2 terms to get the natural log of x times x plus 1 cubed. And then finally, we can use the reverse of rule number 3 to combine those 2 terms into a single logarithm, the natural log of the quotient. Okay, now let's integrate this with something we've learned in the previous video, basically the natural log of e equals 1. We know that the natural logarithm is an antiderivative for 1 over t. If we want to evaluate this integral, we take that antiderivative, the natural log of t, and evaluate it at the endpoints. So the integral from 1 to e squared of 1 over t dt is the natural log of e squared minus the natural log of 1. Since the natural log of 1 is 0, that's the natural log of e squared. Now we can use rule number 4 to deal with that power. That's 2 times the natural log of e, and we know by definition that the natural log of e is 1, so that integral boils down to the number 2.